All right, hopefully everyone saw us coming. You're going to implement quick and merge sort for the array. And so quick sort or Q sort, M sort, and then run the sorting algorithm you believe is best. I'm just there to make you think about which one you think is better for the array. And then for your singly linked list, implement some in-log-in sorting algorithm you wish for the singly linked list, aka not bubble or selection or insertion, aka either quick or merge. Performance graph. Generate a graph to compare the performance of, you choose one, that's why it's in set notation. You choose bubble sort, selection sort, insertion sort versus the quick sort for the array. So I'm specifically calling out quick sort here. Do you have questions or no? And then again, bubble selection or insertion versus the sort you chose for a linked list. Those n-squared algorithms should have already been implemented in a previous lab, and you're going to implement these in-log-in ones in this lab. Generate a performance graph because I want you to see how big of a difference it is, because it's actually a crazy difference. Make sure you label each graph line, turn it in as a PDF. We went through that in GNU plot. To do October 16th, a week from today, we are going to do one of these sorting algorithms in class. So I will let you choose. Which one would y'all like?
Yeah, but
Quick?
easy. No question.
Oh, what's funny is quick is easier to implement, but that's what y'all chose.
Quick, put it back in March.
Oops, that's not what I meant. All right, so sort unit.cpp. Do I need to separate y'all two?
Reminds me of like middle school.
What am I doing? Oh yeah, I'm coding things.
Scolding us.
Scolding, oh that's what it is. I don't think I've scolded y'all yet. All right, let's create an array. 13.
What's the actual definition of scolding?
Isn't that yelling sternly in disapproval of something or another? Look it up on the Googles. I'm sure they have a definition that we can disagree about.
That's still not as bad as like handing out cards and being like, okay, go sit with your group. Rearrange seats for everyone.
They did that in my cafeteria.
They just did that in calculus yesterday. No, not yesterday. Monday.
Yeah, that's fine. Although, I always somehow ended up in the same spot
You can talk to him about that. He's sleepy.
He was up at 6 in the morning.
He's getting ready for the English exam tonight.
You, Cameron? Okay. Wow. All right, so what's the first value supposed to be? No, I don't think it's, what if that, no, that's what he was saying while he's dying. Yes, but you don't actually say that. That's the Holy Grail, sorry. Castle,
That's how I feel.
all right, what comes next? Actually, let me make this 3, 4, 5, 6, 7, 8, 9.
We do 11.
2.
Or up till index 11. Because there's 12. You were close. Oh, I got 2.
I was just going to fix it later, but apparently you want to be more proactive. What's 7 next? What's next? Then,
9,
then
10, 11,
13.
13, 15.
you said 19? All right, let's make sure we fail. Yep, we fail.
That's the first time.
What's that?
That's when you pass the first time without writing code.
Yeah, you're like, we did something wrong. Oh.
Let's write something and turn it in.
Yeah! All right, quick sort. Okay. So what's the first thing we need to do?
Make,
Make it a pivot.
A pivot. All right. Int pivot equals a or y sub 0. All right, we're making our lives easy. Let me see if I can reload these lectures. Maybe that'll help. Excuse me. Is it 18? Are we on chapter 18? Sure we are. Yeah. Quick, remember all that. All right. So we chose a pivot. I skipped this part up here, and I just chose the first number to make our lives easier. So we need to have a lower list index and an upper list index. Okay, so
I was trying to think of like comparisons.
you know you're doing good. Lower index equals lower index, comma upper index, right? And then the lower index equals the upper index, which equals 1. Because they're both, actually, hold on, that's a lie. Or maybe it's 0. I don't know yet. But we do need to go through the rest of it. Equals 1. I is less than size, I plus plus. All right. So, lower index and upper index may be wrong. I just gave them zeros just to get us started. So we need to start with 7. What do we, or start with 7? Start with the first number. And what are we going to check?
It's less than our pivot.
Yeah, okay, less than pivot. All right, great. And what if it's less than our pivot?
Lower index is going to be equal to that, but it also needs to be, wait, it needs to be at lower index.
Right, so
It needs to swap.
it needs to swap with, so if it's less than, it needs to swap with actually the lowest of the upper index, right? Sorry. So think of the general case, that may help. So 11, which is less than 52, what does it need to swap with?
Then 96.
The 96. How do we get to the 96? Oh, they're using small index. Sure, we'll use small index.
So it would be small index plus 1 is the easiest way to get to it?
Right, so small index will start at 0 because it starts over here. So small index plus 1. Okay, so you're swapping with small index plus 1. So now we need to write a swap routine. Wait, where's code? All right. How'd you get to not tab out? Hey, hang on a
Try
sec.
tab and it won't work. Oh, okay.
You weren't in insert mode. So let's swap it. Then erase of small index plus 1. Just picture of okay.
I'm alive.
So Holland's connected, but not Ryan. Let's see. Yeah, that'll work. Great.
Yeah.
And then if it is less than, you also need to increment small index, because the small index got bigger, right? All right. And
Copy and paste for the next one?
for what, greater than?
Yeah, and then.
Well, no, if it's greater than, what do we do? So if 58 is greater than 52, do we update small index? No. Do we swap with anything? No. So we only have to do anything when it's actually less than the pivot value. So on greater than, we do nothing.
Do we have to move the greater index?
Wait,
No, because that's what regular index is, AKI.
Okay.
oh, you got rid of the upper one.
Yeah, I got rid of the other one because they decided to do it this way, which is actually simpler. Okay. So that means, that's great. So when we're at this point, small index is pointing here, pivot's here. What do we need to do next? Now that we have,
Those two.
all right, go for it. Just pivot.
Oh, just for
Yeah, because we made pivot the value.
Now what do I still call pivot here?
That'd be a race of 0.
Okay. But what if it changes? Do we just deal with that later?
Well, you actually didn't need a temp value here because, hold on a second. Yeah, you did. Yeah, a race of 0 equals temp.
Is it just small index? Oh no, it's
No, temp. Because temp is the old one. You're replacing it with pivot, which is really just a race of 0. And then, okay, great. All right. I'm going to, yeah, I'll just let, that's good. All right. Now that it's like this, what do we need to do?
Do a similar thing for the lower sublist and then the upper sublist.
And the word we use for that is recurse. So I'll get you started. Quick sort. Well, in the first one, you're going to start with array because you're going to start on the lower list starting right here. But how high are you going to go up to? I mean, how many elements are there?
Size divided by 2 minus 1.
Not necessarily, because in this case it was cut in half. But remember, quicksort may not actually cut it in half. But you do have a variable that may help you.
Well,
So,
then we just swap it with pivot though.
well, no, but small index is telling you the size of it, right? So small index was 0, 1, 2, or I'm sorry, 1, 2, 3, 4, 5, 6, 7. And small index here is what? 1, 2, 3, 4, 5, 6, 7. But you only need to do the 6 is 1, 2, 3, 4, 5, 6. So it's small index
-1.
minus 1. Okay. The next one is quicksort. Now, you don't want to start here. You want to start over here, right? So that'll be ARY plus, and what are we adding?
Small index +1.
So let me think about that. 1, 2, 3, well, I'm sorry, that's 0. So that would be 1, 2, 3, 4, 5, 6, 7. So it's not plus 1, it's just small index. All right. Are we done?
Maybe.
Maybe. You want to run in and find out what happens?
Sure.
Yeah, we get an error. Too few arguments. Oh yeah, we forgot to pass the size. What's the size of this guy up here?
Small index.
Not necessarily, because small index may be 1 over here, in which case it definitely wouldn't be 1 up there.
Size minus small index.
Ooh, that's a good guess. Let's see what that is. So size, what's the size of this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So small index was 7, so that'd mean it would be 7. 1, 2, 3, 4, 5, 6, 7. So that sounds pretty plausible. All right. All right, you ready to run it? All right, whoever has the small screen, make it bigger. All right, then I guess I'll have to print it here. What was it, 14? I don't know why I did that.
Why is that gonna be 14?
Isn't that the number of values up there?
No.
Oh, how many values are there up there?
12.
Good talk. Good talk. Did it do anything? It didn't do anything. You know why it didn't do anything? Take a guess.
We didn't return anything.
You didn't call the function.
We didn't call the function. The number of times I do this is insane. This is
Yeah.
silly me.
Try it again.
All right, let's find out what happens. There we go. Segmentation fault. Oh boy. Well, we couldn't run Valgrind, and that would actually tell us the problem. But I'm going to give you a big fat hint. We're doing a recursive function. What did we forget to do?
Write a base case.
The base case. Ah!
This is the easier one to implement?
Yeah.
That's what I'm saying.
Wait, how can you not say that? We're up to 21 lines of code. This is going to be under 30 lines of code. All right, what's the base case here? Let's make this easy. If size is less than,
0?
not just 0, 2, return. Because if the size is 1, what's a wonderful feature of an array of size 1?
It's already
It's already sorted. Now we're still going to segfault. All right, so, and well, let's go ahead and run in Valgrind. Stack Overflow. What does Stack Overflow mean?
It's where you find answers to your problems.
Good guess.
Is that when you're stacking your heap?
Yes. So how could that have happened in a recursive function? We kept calling the recursive function over and over again. So we're not terminating at some point. Let me help move this along.
Our size is always 6.
Size is constantly 6 at some point.
But
Then-
does it start off at 6 too?
Well, the problem is that means that one of these algorithms, or one of these functions, is not actually making anything smaller. When could that happen? Well, it couldn't be here. It has to be over here where size minus small index, because if small index is 0, then we're not chopping something off. So let's go back and evaluate our small index. So 1, 2, 3, 4, 5, 6, 7. And we need 1, 2, 3, 4, 5, 6, 7. So this was probably a bad example. But if pivot small index was over here at 2, 1, 2, 3 is being used up. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the size is, what was the size? 14? Maybe it isn't there. So let's go look up right here. Small index minus 1 equals. Was it backslash n? Yeah, there we go. Wow, that is not what I meant to do. Let's show it again. And this is size minus small index. So its size minus small index is always getting back 6. But if the pivot's in the right location, then shouldn't we subtract another one off? Possibly? Maybe? Let's see if that does it. Do y'all see what the problem is? The size right there is not getting smaller. And then you'd have to add 1 to that side, so it does the other side. Let's see if that fixes it. Oh, but now we fail. Probably because we're going back to this issue, we're not including this first value. So,
Plus 2.
nope, not plus 2. I guess there's different ways to do this. If size minus small index equals, or actually just do this. If small index equals 0, because small index is 0, then you really want to do array plus 1 and size minus 1, because you know that the first value is in the correct location, so you need to chop that one off. All right, we're almost there. What do we miss? Ooh, the 8 and the 9 didn't get swapped. That's not good. 10, 11. Ooh, we're just missing one number now. Okay. All right. Let's see. Let me see if I can see it. One moment. Let me look here. I didn't double evaluate. Arrays less than pivot starting at 1. Great. Small index plus 1 equals array sub I. Is the temp. Small index is incremented. Okay. Temp is, or this is where I get confused. Because shouldn't it be because we already have the pivot. That's probably not going to make it. That doesn't make a difference. Yeah, didn't think that would make a difference. Good. And then over here, small index minus 1. That sounds good. Or does it? What if small index goes all the way to the end? Small index goes all the way to the end. Is that going to mess anything up? No, because you're going to swap it and you subtract 1, right? Great. Hmm. Oh. All right. Let me see if I can make this pop out for you. One thing to do if it's not popping out is to go ahead and print off all the numbers.
You forgot a semicolon.
Thank you. All right. So, right before it recurses, we probably should have told you what pivot is, otherwise it's not going to be too helpful. All right, whoever has a small screen, I guess I'll dump it to a file. Okay, so at this point the pivot is 13, so 13 is right here. Are we good? That looks fine, right? And then, oh, what happened here? Negative 21, where'd the 11 go? It's gone. Looks like we chopped something off we didn't mean to chop off. In other words, I think we subtracted 1 from small index when we didn't need to. Do y'all see how I got to that? Maybe? You're disagreeing with me because it's been too long? Well, I didn't check to see. Yeah, and then we're okay. So we'll go get rid of these. Well, no, I'll keep them in there for you, in case you need to start debugging, but I doubt you do. Okay. So we've covered up quicksort real quick. Ha ha ha. Merge sort's going to take you a little longer. But merge sort might be a little more, what's going to be the word?
Straightforward.
Intuitive, yeah. I highly recommend you write a merge function, which merges 2 arrays into another one, or not, just do it in the code, whichever is easier for you. I guess for a linked list, a merge function would make more sense. But for an array, that might be difficult because of the memory. I'll let y'all figure it out. Do it either way. Any questions? Comments? Screams? Groans?
You didn't bring the bottle of tears.
No, you bring that to me.
But you have it in
We're
your
the ones
office.
crying.
What?
We're the ones crying.
But that bottle's full already. I need
need
more
more.
capacity for when I really want to sit down and enjoy it one
That's
evening.
when you need to make a new bottle, i.e. another array, because you can't expand the current one.
Just means more to me when the student brings a bottle.
It's like an offering.
Yeah, it's an offering. That's exactly what it is.
Does the offering get you a higher grade?
Yeah.
No.
Only appreciate.
Right.
Sometimes not even that.
All right. So that's it for today. You have, how many labs you have now? I don't know, 3 labs. Assigned project 2. Midterm's going to come out soon.
Ethics paper.
Ethics, what does ethics paper do?
Let's do the end of the month.
Okay, good. So that's not part of your midterm.
3 weeks from today.
Nice. Nice. Don't forget your
Which
ethics.
is what I thought the project
Yeah,
was going to be,
so much
but it's due
progress.
the Monday instead.
Right. Yeah, I wasn't going to do that. No, because we have to cut off days and shift things together. The third project, the problem is I got to give you a good amount of time for project 4. Because at the end of the semester when everything else is due, And project 4 is, that's my favorite project.
Interesting.
It's a great project. Well, the performance, I have performance numbers ranging from a 60 to 140. So there's so many things you can do with project 4. It's beautiful. It's
Is
wonderful.
it gonna be due the last week of class?
Sure. I
I'm
don't
not
know.
asking it to be, I'm just asking. it
It'll
to
be, I'm gonna give you as much time as I believe is correct. I don't know if I'm allowed to assign you a project over reading days. That's the only problem. I'll have to go look that up. So, all right. Any other questions? Comments? Nothing? All right, guys. Well, enjoy your fall break.
Sure.
No.
Architecture's not like this. Yeah, it's not like
What
this.
about operating system?
Oh, operating systems. I don't know. Maybe by the time you take it, I'll finally get it up to data structures level, but I haven't been able to yet.
No.
So it's harder.
How about do that for
Or
the
like
fall?
more work, is what you're saying?
Right now, operating systems is all bookwork, which is lame. Lame, lame, lame. But that's because there are very few resources about building an OS, because I mean, we want to build a kernel. Okay, hang on a second. Well, we don't have, you know how you have these libraries like the STL, and you have malloc and free. Yeah, those are gone. Completely. Gone. Completely gone.
All by hand.
Yes.
Dude.
So you have a processor that knows how to execute instructions. That's what you got.
So are you saying there's a lot of scripting in that class?
No, scripting would be, wait, if you wanted scripting, someone would have to build an interpreter. Who wants to build an interpreter in Assembly? Anyone? Bueller? No one? Yeah, so no. Ain't nobody got time for that. There's a lot of that in OS, by the way. Well, the other thing is, you want USB to plug in your USB devices, right? Well, the USB, I think 1.0 specification is 500 pages long. Anyone want to do that in a semester class? Anyone? No? Again, ain't nobody got time for that. So we end up having to do some, I'll say, interesting shortcuts. Yeah. But it'll be good. It'll be wonderful. Did I stop recording? No, I didn't. Perfect. By the way, if you want to do the programming competition, make sure you email me. You're still interested? Maybe?
Maybe I'll see with like work.
Okay, well, I need to know today, so email me today. I mean, you can email me tonight, that's fine, but when I wake up tomorrow morning, that's when I gotta figure this all out.
Gotcha.
So, possibly, just email me. It's one Saturday, it's not even the whole Saturday. You don't even have to get up for a data structures class. No other questions? All right, guys, now have a good